doing the first question, and that is to factorize. Two fairly straightforward questions on factorizing. So, and we're going to try and stick to the time limit for the marks. So if you see on your paper, it's a 1 mark question, then you generally have 1 minute to do that question. So you can generally work on a mark a minute. Okay, so I'm going to leave you here so that you can try these 2 questions, and hopefully we can do it in 3 minutes because it's 3 marks. But if you are done, don't put an answer in the chat. All I want you to do is to just put a thumbs up when you are done. Okay, off you go. Give it a try. Tombizodwa, you don't need to put answers in the chat yet. You can just indicate that you are done by putting a thumbs up. Okay, we've got 1 more minute, everybody. Okay, our time is up. Let's have a look how we're going to do 1.1.1. We're going to take out a y as a common factor. And if we take that first term and we divide it by y, we are left with 3y. And the last one, if I take a y out from the y, in other words, if I divide y by y, I get 1. And then you always check when you factorize if it works. So y times 3y gives me 3y squared. Good. And then y times a plus 1 is going to give you a plus y. Okay. Guys, just a reminder to please remain on mute. There is someone whose mic has gone on. Miss Nelly, if you could just maybe have a look who it is. Okay, so that was the first one. And the second one, we've got 1, 2, 3 terms. There's an x squared term and an x and then a constant. This makes it a quadratic. It's a quadratic when it has that x squared and an x term and a constant term. So this we're going to factorize by making 2 brackets. So x squared I get from x times x. And then I need to figure out which factors of negative 24 is gonna cross multiply and add up to negative 10. So Melly says it is x minus 12, x plus 2. I totally agree. And remember, you can always check. Minus 12 times a 2 gives me minus 24. Good stuff. And then if we take the minus 12 plus 2, add it together, you get minus 10. So that works as well. Good job. Okay, so that was our first warm-up round. Can I see who got both questions right? Put a thumbs up in the chat if you got both questions right. Amukelani and Lunello, well done. And Hartis, Untatilen, Meli, Ntombizodwa, Lydia. Awesome, there's a whole bunch of you. Well done. Okay, let's carry on. We're now going to go to the fractions and let's see what we've got here. Simplify the following expressions. So to simplify means we have to multiply out, but in general, when we do this, we are making things simpler. The questions are similar to the ones I wrote on my exam. There you go, Lunello. So this is it's a good paper, like I said at the start. It is set by the Department of Education, so it is a good indication. Department of Education, so it is a good indication of what you might expect. Ayanda, why are you only owning up now? We asked who is new and you kept quiet, but welcome. It is good to have you here. Ayanda kept quiet the whole time about being new, but welcome, Ayanda, and we hope to see you back here many more times at Watobe, and I hope you enjoy your first lesson with us. Okay, so let's carry on. And I'm going to give everyone, so this is 2 minutes, and I'm going to give everyone a chance to do question 1.2.1, the first question. And when you're done, put thumbs up in the chat. Okay, so this is your chance now to practice and really see where you do not understand stuff and where you are stuck. So make sure that that participation level is right up there this afternoon so that you get all your questions answered. Right, so when you're done with 1.2.1, thumbs up in the chat. Those of you who want to work ahead, that's fine, but don't rush. Put a thumbs up when you are done with 1.2.1.
Ma'am, sorry, can you please just zoom in for question 1.2.3? I think they constitute the exponents.
Oh, remember you can zoom in on your own screen as well.
Thank you.
And if you're on the phone, you can do it too. Okay, let's do question 1.2.1. So we're going to FOIL like we always do. We do have fractions, but remember when we multiply with fractions, it is always numerator with numerator that we multiply and denominator with denominator. So if I look at this 4, it's actually 4 over 1, and this is 2 over 1. So if I want to multiply that, it's the same as going 4 times 2 is 8, 1 times 1 is 1. And it's going to be the same for where I have x's. Okay, so 4 times 2 is going to give me 8. Sorry, my screen just jumped. So I'm just going to undo. There we go. So that's 8. And then we're going to multiply the 4 with the negative 3 over x. So we go 4 times negative 3 is going to make it negative 12 over x. And then we're going to multiply the other term. The 1 over x, we're going to multiply with 2 over 1. So that's going to give me plus 2 over x. And the 1 over x with the negative 3 over x, which will give me negative 3 over x squared, because x times x is x squared. Okay, now we can just simplify. There's these terms are like, they have the same denominator, so we can add them. The 8, there's nothing to add to the 8 because it's not like with anything else. But minus 12 over x plus 2 over x is going to give me minus 10 over x. And then the minus 3 over x squared also doesn't have anything that you can add to. Right. Give a thumbs up if you got that one right. No one got that one right. No, he says no. Ntombi Zodwa, nice. And Lashandre. Good. Okay, be ready for these ones, guys, because this is part of your grade 10 work that they do. You know, they like to ask this. So take screenshots, and tomorrow when the recording's out, if you want to have another listen to it, there you go. You're welcome to. Okay. Next one is 5x minus 5 divided by 5x. So 5x minus 5 divided by 5x. Now, we can separate the terms out. There's 2 ways to do it. We can go 5x over 5x minus 5 over 5x. And then cancel top and bottom. So 5x goes into itself once and into 5x once as well. If you divide 5x by itself, basically it is 1. And then here you have 5 going into itself once and into the other 5 once as well. So that's minus 1 over x. What you could also have done, I don't know if anyone did this, but you can factorize the numerator. So you can go take out 5 as a common factor, and then you're left with x minus 1 over 5x. And then you can cancel the 5s, and you have x minus 1 over x. Also perfectly acceptable. Okay, so if you did either one of those, let us know. Put it in the chat if you got a thumbs up for either one of those solutions. And if you're getting something wrong, you must ask a question. Make sure you understand why you're getting it wrong and how to fix it. Please don't leave here today. This is an important revision session where you can clear up anything that you are not sure about. Okay, where's the rest of the class? We are about 30, so let's get some more thumbs up, thumbs down, so that I can just see how everyone is doing. Okay, right. I'm going to go on to the last one. So we've got 3 to the x plus 1 plus 3 to the x over 27 times 3 to the minus 1 plus x. Okay. Now, a few important things here when you're working with the exponents. First of all, you can only have prime number bases. So if anything, any of the numbers are not in as a prime number base to its power, you need to change it. So if we look at this first term, 3 is prime, 3 to the x, that's prime, but the 27, we need to just quickly change that. And the reason we do this is because to work with exponents, we need sameness. We need things that are the same. We can only multiply exponents with the bases that are the same. All the laws of exponents depend on sameness. Okay, so we need to rewrite things so that they are the same. So 27, you can change that to 3 to the power of 3 instead of the 27. And now you only have 3s. So everything's got the same base now. Okay. Now, the next thing that's important is when there are terms that are separated by pluses or minuses, you cannot cancel out yet. You first have to factorize. Okay, before you can start dividing and doing stuff, you first have to factorize. So we can take out between these two terms, 3 to the x plus 1 and 3 to the x, we can take out 3 to the x. And, okay, let me make a bracket. And then what's left, if I take 3 to the x from this first term out as a common factor, then I'm left with 3 to the 1, and here I'm left with a plus 1. And here I have 3 to the power of 3, and then 3 to the minus 1. I'm going to break this up so that it's 3 to the minus 1 times 3 to the x. You can do that. You're basically just going back to what it was before you added the exponents. Because if you multiply and the bases are the same, you normally add the exponents. So the way it is here, if you take it back to what it was, separate bases, then sometimes it's easier. Yes, Ntombi Zodwa.
Ma'am, I just wanted to ask you here where you wrote 3 to the power of x, then in the bracket you said 3 to the power of negative of 1. Won't it be, if we multiply it, won't it be, if we multiply 3 by 3, won't it be 9?
What if I multiply what?
3, this 3 to the power of x
Yeah.
with the 3 to the power of 1.
Oh, you are asking if 3 to the power of x times 3 to the power of 1 is not 9 to the power of x. Is that what you're asking?
Yes, ma'am.
I'm
Yes,
really
ma'am.
glad you asked that question, because the rule of exponents, the law says, and it's like the law of anything, we have to stick to it. But before we can stick to it, we also need to know it first. So the law says when bases are the same and you're multiplying, you add the exponents. The law doesn't say when bases are the same, you times the exponent, the bases together. And so this here gets us back to 3 to the x plus 1. Now let's look at what this is. This is actually, if I change that 9, it's 3 squared to the power of x, and that is 3 to the power of 2x. Do you see it's actually not the same thing? This does not equal this, but 3 to the x plus 3 to the x times 3 to the 1, that takes me back. If I follow what the rule says add the exponent. So you write the 3 as the base, and you take the x plus 1. And that takes me back to what I had at the start. Okay, which makes sense because it's everything has to be equal. All right, so yeah, don't multiply the bases together. You leave the base as it is and you just add the exponents together. So let's see what we can do here.
Okay, thanks, ma'am.
Okay, thanks, Ntombi Zodwa. I'm glad you asked that question because many people make that mistake. So I hope everyone is clear that we do not times the bases together. We leave the base as it is and we just add the exponents together. So here we have 3 to the x and 3 to the x. That can now cancel or divide. And what can we do here? We see we have a 3 to the power of 3 and a 3 to the power of minus 1. Those bases are the same. We can add the exponents. Okay, so I'm going to leave what's at the top, 3 to the power of 1 plus 1 over. So the 3 plus a minus 2 is going to give me 3 to the power of 2. I hope you guys see that we are not, the 3's have not changed to 9's or anything like that. Okay, and all we got left to do now is to simplify. So 3 plus 1, that's 4, and 3 squared is 9. So it's 4 over 9, that's our final answer. And only when all the x's and all the brackets are gone and you factorize and everything can you do that at the end where you simplify the numbers. 4 over 9. Anyone got this one right? If not today, then definitely in your exam next week, okay? Anyone got it right? Okay, not to worry. You can try it again. And I definitely think it's time to go over that and make sure that you are ready for that type of question when it comes. Take screenshots, guys. Take screenshots and ask more questions if you're not sure how we got to these answers. Right. I'm going to give it 30 seconds in case anyone else still wants to ask a question about these pesky exponents. All right, if there's no more questions, then we're going to leave the algebra. So that's your algebra. You got to know how to multiply out. You got to know how to factorize. And you got to know how to work with exponents. Let's see. Here we are, equations. Okay. Have a look. I'm going to give you 2 minutes for this first one. Don't go on to 2.1.2 yet. Just do this first one, 2.1.1, and we'll check in about 2 minutes. Let me know when you're done by putting your thumbs up in the chat. Yes, Masejo. You can unmute and ask a question.
Ma'am, on 2.1.1, I always get stuck on I don't know if it's the second or the third step, but I just want to wait for everyone to finish so that I can say something. Is it fine?
No, it's fine. I think they've been busy for a bit, so you can ask.
So, ma'am, I said 2x, I took out 2x as the common factor. Then I said 2x open bracket x minus 5 equals to 0. So that is where I got lost. I don't know what to do after this step. What do I do, ma'am?
Okay. So you got that, right? 2x,
Yes.
x minus 5. Okay, that's perfect the way you did it. Now, this is actually a quadratic equation because we've got an x squared and an x. It's just a quadratic equation without a third term. So factorizing it was the right thing to do. So if we go back to like another quadratic equation, which you normally have, like say you have something like this. Okay, would you know what to do there?
Ma'am, I think since it's a quadratic equation, there has to be two answers.
Yes.
So one x would equal to -5 and the other one to +2, if I'm not
Perfect.
mistaken.
Yes, perfect. So we're going to do exactly the same with this one, with 2.1.1, because it's also a quadratic equation. And like you said, there needs to be two answers. So we're going to say 2x can equal to 0, or x minus 5 will equal 0. So just because this is not a bracket doesn't change the fact that you've got two things being multiplied, and one of them can equal 0 and the other one can also equal 0. Okay, but it is a quadratic equation. So then when we have 2x is equal to 0, then that x is going to equal 0, and this one is going to equal 5. Okay.
Okay, ma'am.
Okay, so it's the same as what you would do with one that had two brackets. You'd put whatever you're multiplying, the 2x or an x, if it's just on its own with the bracket, you'll take them both and put them equal to 0.
Okay, thank you, ma'am.
All right. So who got this one right? Thumbs up in the chat if you got it. If you got stuck, no problem. Good, Lydia. Tombi Zodwa, Leah, well done. Okay, everyone else, remember, ask questions. Okay, so let's see how we can do 2.1.1. I'm going to do this one because I am aware that some schools might not have done this work just because of the curriculum and yeah, it might have been cut by some schools, but basically we need to get the x by itself, right? Because we are solving for x. So I'm going to take the first two terms. I'm going to take out x as a common factor and get p minus k, and that's equal to k minus p. And then to get x by itself, you need to basically get rid of the p minus k. And to do that, we're just going to divide by it. K minus p divided by p minus k. So if it's the same principle of like a normal equation, solving a normal equation, you just need to get x by itself. Okay, right, let's go on to 2.1.3, which is quite important because this is something, again, it's exponents, and it's also part of what you would have done this year that was new, different to grade 9. So let's make sure that everyone's able to do 2.1.3. Okay, who's done with 2.1.3? Just put a thumbs up if you're done. Dia says they're done. Okay, I'll give it 1 or 2 more minutes. Put a thumbs up in the chat when you are done. Remember, the first thing with exponents is those prime number bases. So I see a 1 over 128, and that 128 we can change surely to a base 2 to some power. And you can do that on your calculator. You just put in 128 and say equal, and then shift, and there's a button that says fact. It will give you the prime factorization for 128. Okay, 1 more minute, everyone. We do need to make sure we get through everything today that we need to get through so that we actually finish a paper in 2 lessons. Right, let's have a look. If you're not done, no worries. Just make sure you follow along on the screen. So 2 to the power of x over 3 is 1 over 128. So like I said, that 128, we can't do anything with it until it is to the base 2. So check on your calculator. 128. I'm actually just going to go grab my calculator. Oh, there, Harties has it. It's 2 to the power of 7. So for those of you who didn't know that you can use your calculator for prime factorization, you just go 128 equals, and then shift, and there's a button with lots of commas on it, and above it, it says fact, and it will give you that 128 is 2 to the power of 7. But this is 1 over 2 to the power of 7. So what we're going to do is just change that over so that it is 2 to the minus 7. Now, we do that. Remember from grade 9, your exponent rule is if it is below the line, 2 to the power of 7, and you want to put it above the line, in other words, not have that fraction, then you just change it over, but you need to change the sign of the exponent. Sign of the 2 doesn't change. It's the sign of the exponent that changes. And now that we've got bases that are the same, we can make the exponents the same. So x over 3 is the same as negative 7. So x divided by 3 is the same as negative 7. And if x over 3 is negative 7, to get rid of that 3, we times by 3 right through. So if I times negative 7 by 3, I get negative 21. Okay. Right, ask a question. If you got it right, brag about it in the chat. Let us know that you got it right. And again, like I say, make sure. Nice, Eunice. Well done. Excellent.
What about everybody else?
And Lydia, well done. Yes, Mitheni, I'm also wondering about everyone else who have just gone quiet. Ontatile got it right. Well done. And Harty's got it right. Excellent, you guys. Everyone else, remember, ask questions and take screenshots and rewatch the recording if you want to go through this again. Okay. Right, so let's go on to an inequality. So inequality, and you can also expect one. Ayanda also got it right. Well done, Ayanda, on your first day here. It's good to see that you're participating and finding this useful. Okay, so x plus 5. Masego says she loves inequalities. Okay, so we're going to solve for x, and the first thing we need to do is maybe not have that fraction there. So if it is divided by 2, we are going to times by 2 to do the opposite. So if I times by 2 on the left, I must times by 2 on the right. And then we're going to take the plus 5 to the other side by subtracting it, and we're going to have minus 4 minus 5 is minus 9. Okay, so yeah, a few things to remember about the inequalities. If you're dividing or timesing by minus, you need to flip your crocodile the other way. Okay, crocodile is these things, so going that way and that way. So if you are timesing by a negative, the crocodile starts swimming in the other direction. Okay. So this says x must be greater than minus 9. So 2.2.2. We need to draw a number line for this. And it doesn't have to be a very involved number line, guys. You can just make a line with a ruler, preferably. And it says if x is element R, in other words, x is a real number, represent the solution on a number line. So you can just show here is minus 9, and your arrow, because x is greater than minus 9, it is going, your arrow is going in that direction where the numbers are becoming bigger. And we're not going to color in, because there's no equal in our inequality sign here. It's just x greater, not x greater than and equal. So that's it. That's all you have to do. That is sufficient. Okay. Right. We have a few minutes left and we are going to go on to patterns. Okay. Question 3. Remember, as part of your paper 1, you also need to do simultaneous equations. And if you're wondering about simultaneous equations, have a look on our website. There will definitely be a lesson on simultaneous equations. Okay. Have a look, and if you think you know, pop in the chat, what is the next term in this pattern? Nice, guys. Nice. 5x plus 7. I totally agree. Right, in terms of x, the formula for Tn, the general term of the pattern. Does anyone know how to do the general term of the pattern? Give it a go. And if you think you've got it, pop it in the chat. Does anyone have it yet? Okay, and if you want to go on, what is the value of the 13th term? If the value of the 13th term is 95, calculate the value of x. We might be running out of time. So I think what I'm going to do is just get the memo for us. Okay, so you're welcome to take a screenshot of the memo. But basically what we've got is that the Tn which you can do. I see you guys know different ways of doing it. an plus c, or a plus n minus 1d. That is fine. You can use either one of those formula. So the first thing you need to do, though, is determine the difference between the terms. So what is the constant difference? And you can do that by just going 2x plus 1, or actually 3x plus 3 minus 2x plus 1. And that gives me 3x plus 3 minus 2x minus 1. And that gives me x plus 2. So each time you're actually adding x plus 2. And if you put that into the Tn formula, whichever one you learned, so if you learned a plus n minus 1d, then your a is your first term, so that's 2x plus 1, and n minus 1 is part of the formula, and then d is your constant difference, that's 2. So you substitute that in, and you can multiply it out, and then you'll actually get the answer that they've got here. Okay, the other way to do it is using Tn as mn plus c, which is that constant difference times n plus whatever your c is. Right, and once you have that, you can do 3.1.3 and 3.1.4. But we have unfortunately run out of time for all of that, so you're welcome to take a picture of this question and then another one of the actual memo as well. All right.